Okay, so this is the second video. So what we're going to do is derive a formula for capacitors in series, much the same as we did for resistors last year. So what we have here is three capacitors connected. Now, just like a series circuit, the voltage is going to share amongst the three. So there'll be V1, V2, V3. Now, because of conservation of charge, there must be the same charge on each plate. Okay, so because of that, it must be the same charge on each plate. So if we went through the plates and said, well, there's minus Q on that plate, there must be plus Q on that plate. Minus Q plus Q, where Q is the same value for each. Okay, and this one is capacitor 1, capacitor 2, capacitor 3. Now if we said, well, from the definition of capacitance, C1 is equal to Q over V1. C2 is equal to Q over V2. Remember, Q is going to be the same for each. And C3 is equal to Q over V3. So rearranging for V's, V1 equals Q over C1, V2 equals Q over C2, and V3 equals Q over C3. Now the total voltage, because it's a series circuit, is just the three voltages added together. So if we add that one, and that one together, you get the total voltage. So in other words, V total, because V1 plus V2 plus V3, so that is equal to Q over C1 plus Q over C2 plus Q over C3. But we know that the total voltage is equal to Q over C total. So Q over C total equals Q over C1 plus Q over C2 plus Q over C3. Hopefully you can see we've got a common term here. And we can simplify it as 1 over C total is equal to 1 over C1 plus 1 over C2 plus 1 over C3, etc. So here we have an example of two capacitors in parallel. So if we just work it out, 1 over C total equals 1 over C1 plus 1 over C2, so that equals 1 over 12 plus 1 over 6. So that equals 12 over 3 if we flip both sides, and that makes 4 microfarads. So another example here. A 12 microfarad capacitor is connected in series with a 6 microfarad capacitor. What is their combined capacitance? So here we have two capacitors connected in series. One's 12 microfarad, one's 6 microfarad. So what was their combined capacitance? Okay, so we've just done that in the last page. That's just going to be 4 microfarads. So B, what's the charge on each capacitor? Well, the charge is the same for each one, so you just work it out in total. CV, Q equals CV from C equals Q over V. 4 times 10 to the minus 6 times 36 volts. And that will give you 1.44 times 10 to the minus 4 coulombs. II, potential difference across each one. Now this is shared, okay? So let's say we're doing the voltage for the 12 one. we do the charge on the 12 one, which is the same for both, divided by the capacitance. So 1.44 times 10 to the minus 4 divided by 12 times 10 to the minus 6 gives you 12 volts. And if you work out the other one, you get 24 volts. So in other words, they both have the same charge, so we needed twice the voltage on this one to get the same amount of charge as that one. Okay, so capacitors in parallel. Okay, so for this one, across all of them, the voltage is the same because it's in parallel. Okay, so we have C1, C2, and C3. On each side of the capacitor, the charge is always the same. Charge is the same on each side. So what is the total charge? Each side of the one capacitor, but each capacitor could actually have a different value of charge. So Q total equals Q1 plus Q2 plus Q3. In other words, if C1 was bigger than C2, then C1 for the same voltage, they've all got the same voltage, so C1, if it was bigger than C2, would have a greater charge on it than C2. It was easier to get the charge on for the same push. Now, but we know that Q equals CV, so C total V is equal to C1V plus C2V plus C3V. Removing that common term of the V, sorry, you get the final formula as C total equals C1 plus C2 plus C3, etc.